We are going to look at chapter 7 today, which is estimation. In chapter 1, 2, 3, and 4, we learn about descriptive statistics, how to collect, organize, and summarize data. Chapter 4, 5, and 6, we have learned about probability. And at the end of chapter 6, we learn about sampling distribution of sample statistics, like the sample mean. Now we are going to start with inferential statistic, which essentially is of two types, estimation and hypothesis testing. Chapter 7 is about estimation, in which we are going to learn how to compute confidence interval. The use of calculator will be very, very important here because most of the computation we are going to be using the TI-83, 84 calculator. (7.1) Estimating the mean when sigma is known. As we learned in chapter 1, a measure from a parameter is, a measure from a population is called a parameter, and a measure from a sample is called a statistics. In general, we use statistics to estimate parameters. So we are going to learn how to use a range of values to make an estimate for the parameter. When a specific number is used, it is called a point estimate, and when an interval or a range of value is used, it is called an interval estimate. An estimator is generally a sampling distribution of a sample statistics. We consider it to be an unbiased estimator if the expectation of that distribution is the parameter we want to estimate. It is consistent, that is, the larger the sample size, the closer the statistic is to the parameter. It is relatively efficient or reliable. If it is the smallest, if it has the smallest standard deviation, that is, it varies less than any other estimator for the same parameter. An example of good estimator is the sample mean. Its expectation is the population mean. The larger the sample size is, the closer the sample mean is to the population mean. And the sample mean has the smallest standard deviation. So the sample mean is a good estimator for the population mean mu. Also, the sample variance defined by sum of x minus x bar square over n minus 1 is a good estimator. Here, I want to explain that the reason why we divide by n minus 1 is in order to have its expectation to be the variance. So if we divided the sample, the total deviation or the total variation by n, we will not have an unbiased estimator to the variance. That is why we use this definition for the sample variance. So in computing confidence interval, we need the margin of error, which is the maximum error of estimate. We need to determine what is the difference between the statistic and the parameter and minimize that difference. The confidence interval is an interval estimate computed using a confidence level. Actually, the confidence level is the proportion of interval estimate that actually contain the parameter. So given a confidence level C, the critical point corresponding to C is the standard score ZC, so that the area to the left or the right of ZC is 1 minus C over 2. So this graph explains to us what C is. C is the area between minus ZC and ZC. If we know the area between minus ZC and ZC, then we can subtract it from 1 and divide by 2 to know the area to the tails. That is going to be used to find minus ZC, which is the critical value. So whenever we have the confidence level, we can use this method to determine the critical value ZC. In general, we have on this table the possible ZC given a critical value C. These are the most common critical values that are used. For example, for 90%, the critical value is 1.645. For 95%, the critical value is 1.96. For 99%, the critical value is 2.58. So if we have a confidence level, we can use that confidence level to determine ZC, which in turn will be useful in computing the confidence interval. If the population is normally distributed or the sample size is large enough, when sigma is known, we use the Z distribution, that is, we find the critical value using the Z distribution. And the margin of error E is ZC times sigma over square root of n. And the confidence interval is sample mean minus E less than or equals to mu less than or equals to sample mean plus E. Example, Julia enjoys jogging. She has been jogging over a period of several years, during which time her physical condition has remained constantly good. Usually, she jogs 2 miles per day. The standard deviation of her times is sigma equals to 1.8 minutes. During the past year, Julia has recorded her times to run 2 miles. She has a random sample of 90 of this time. For these 90 times, the sample mean is 15.6. Let mu be the mean jogging time for the entire distribution of Julia's 2 miles running times taken over the past year. Find the 95% confidence interval for the mean. So first we will check if the requirements are met. Here we have a random sample of 90 values. 90 is large enough. So we can consider that the distribution is approximately normal. And now sigma is known. So if sigma is known, we can use the Z distribution. For 90%, 95% confidence interval, ZC is 1.96. So we are going to use it to compute the margin of error. 1.96 times sigma is 1.8 divided by square root of 90. We have E equals to 0.37. So the confidence interval for the mean is 15.6 minus 0.37, 15.6 plus 0.37. So the actual average time for Julia is between 15.23 and 15.97. We could use the calculator, the TI-83 calculator, to do this as well. So you go to Start, and then Test. If you have data value, you can enter it. After Start, you press Edit. You can enter your data value in L1 or L2. If you don't have data value, but you have statistics, you go to Test, and then choose, go down to Z interval, 7 for Z interval. Then because you are using the statistic, you press enter and choose sigma. The value that is provided, it was 1.8. Then the sample mean. The sample mean was 15.6. Then the sample size 90. Confidence level 0.95. And then you calculate. You will see, get a parenthesis that gives you the range of values for the confidence interval 15.23, 15.97, using a calculator. Sometimes we are given the margin of error and we are asked to find the sample size, the minimum sample size. In this case, we use the formula n equals to, I will use a whiteboard to explain this. So we say that E was ZC sigma over square root of n. So if you are given E, the margin of error, you will be asked to find n. You solve for E and have square root of n is equal to ZC sigma over E. I'm sorry. So squaring both sides, we have E equals to ZC sigma over E squared. So this is the formula for the minimum sample size when a margin of error is given. Example, a wildlife study is designed to find the mean weight of salmon caught by an Alaskan fishing company. A preliminary study of a random sample of 50 salmon showed S equals to 2.15 pounds. How large a sample should be taken to be 99% confident that the sample mean is within 0.2 pounds of the true mean weight? So if it is within 0.2, we consider this 0.2 as the margin of error, E. So E equals to 0.2. For 99% confidence interval, ZE is 2.58. ZC is 2.58. And the preliminary study of 50 fish is large enough to permit a good approximation of sigma by S equals to 2.15. So we fit all this into the formula to get N equals to 769.2, which we will round it up to 770. So that's the minimum sample size to get a margin of error of 0.2. Now we want to do the same type of work when sigma is unknown. When sigma is unknown, we use a distribution which is similar to the standard normal distribution, and it is called the T distribution. So it depends on degrees of freedom, which is n minus 1. The distribution, like the Z distribution, is bell-shaped, and as the degree of freedom increases, the T distribution gets closer to the Z distribution. The total area under the curve is 1. The T distribution is given to you in your textbook, and you can use that to determine the critical values. But I will encourage you to use your calculator to find a confidence interval. Here, to find a confidence interval, we still require either that the population should be normally distributed or the sample size should be large enough. Then, if sigma is unknown, we use the T distribution with degree of freedom n minus 1. So this is how we use the T distribution table for those who are not using their calculator to find TC. Use table 7.3 to find the critical value TC for a 99% confidence level for a t distribution with a sample size of n equals to 5. So this is a confidence interval, and C is equals to 0.99, n equals to 5, and n minus 1, which is the degree of freedom, equals to 4. So we go on the row of 4 to identify at 99% that TC is 4.604. So here we are using the critical value to find the margin of error and compute the confidence interval. But you can use your calculator, which is much easier. I will discuss that after we do the computation manually. So when sigma is unknown, we will use the t distribution, and the TC is obtained as in the previous slide, and we have E equals to TC times S over square root of N. And once we have E, we subtract it and add it to the mean to find the interval, confidence interval for the mean. If you have any question, please stop me and I will explain what you are not understanding. So now we are going to do an example. Suppose an archaeologist discovers 7 fossil skeletons from a previously unknown species of miniature horse. Reconstructions of the skeletons of these 7 miniature horses show the shoulder height to be these 7 numbers. For this sample, the mean is 46.14 and the standard deviation S is 1.19. Let mu be the mean shoulder height for this entire species of miniature horse, and assume that the population of shoulder height is normally distributed. This assumption is important here because the sample size is too small. Do you have your TI-8384 calculator with you?
Yes, I do.
Oh, good. So let's use it to compute the confidence interval here. So if you are ready with it, let me know.
I'm ready.
Okay, you put it on and you go to start. Then you press enter for edit. And we want to enter the data values in L1. Just make sure you have no values in L1. Do you see L1, L2, L3?
Yes.
Do you have any value on L1?
Yes, I do.
So to clear it, push the cursor up until you see L1. It has to move to L1, then you press clear and then press it down.
Oh, yeah. Okay, it's cleared now.
Okay. Now we are going to enter this, I think, 7 values. 45.3.
It deleted like the name, and it's like giving me name like L1 or L2 isn't showing, and I don't know why it's like that. Oh wait, there we go. Okay, now I can delete the values.
So you go to start, enter, and then you will see L1, L2. You can delete on L1 by pushing everything to your cursor to L1, press clear and press it down, and then you will see everything going and you start entering the values.
Okay, now I can enter them.
Okay. When you have your values in the calculator, you let me know.
Okay, I have all of them added.
Okay. So we want to find the 99% confidence interval. To find the 99% confidence interval, you press start. And you will see Z interval. You were not there when I did the Z interval, but essentially it's the same thing. Z interval is when sigma is none. In this example, the population standard deviation was not given. That is why we are going to be using the T interval. We use the T interval when the population standard deviation is unknown. So you will go to 8, which is T interval. And you press enter.
Where do I go again?
So you go to start.
Okay.
And then to test. On the side, you go take the cursor right to test.
Okay.
Then you will see several tests, but here we are doing confidence interval. If you look at
it's the Z interval.
The Z interval is used when sigma is unknown. That is what we did in 7.1. When you will come back to it, you will see 7.1 is if sigma is unknown. If sigma is known, if you are given the standard deviation of the population, you will click 7 and proceed. But you will proceed almost the same way, so you are not missing anything, as now when we will go to 8, which is T interval, when sigma is unknown. Do you understand what I mean?
Yes, I do.
Okay. So when you are there, we are going to use data. Do you see data and start?
Yes.
So because we enter data, we are going to use data. If we were given, like in the previous example in section 7.1, we were given the statistic, that is the mean and the standard deviation. But when we enter our data, it's going to work that through. And then you make sure you identify the list. I always encourage you to use L1 because L1 is by default. But if you had used L2, L3, or L4, you will change this list to the list that you used. Then the confidence level is 0.99. Do you see all that?
Yes.
Now you go to calculate. Have you calculated?
Yes, I calculated it.
Do you see a parenthesis with two numbers inside?
Yes, 44.475 and then 47.81.
Yes, that is the confidence interval. You can see it here on the PowerPoint. So if you are not having a calculator, and I encourage everybody to have a calculator, you are going to find TC with the degree of freedom 7, the degree with the sample size of 7, the degree of freedom is n-1, which is 6, and the confidence level of 0.99. You will go to the T distribution to find T.99 equal to 3.707. So we are going to use it here with the computation of the standard deviation, which is 1.19, divided by square root of n. N here was 7. When we do this, we find 1.67 at the margin of error. So we will compute the mean for the sample, and the mean is 46.14. Subtract the margin of error, 1.67, and add it to get 44.5 to 47.8. But if you have a calculator, you will do as we did, using stat and choose T interval. Here you want to be careful, make sure you check that the population standard deviation. A standard deviation could be given, let's say for the sample. That's not the population standard deviation. The population standard deviation is sigma. When it is given, you use the Z interval. That was the option 7. When it is not given, you use the T interval, which is option 8. Okay. So the archaeologists can be 99% confident that the interval 44.5 to 47.8 is an interval that contains the population mean for shoulder height of this species of miniature horse. That's the meaning of a confidence interval. So I give you here again a summary of how to use the TI-8384 calculator. So as I said before, if you don't know the population standard deviation sigma, you will use the T distribution, find the critical value TC, multiply by the sample standard deviation and divide by square root of n. The degree of freedom is always n-1, where n is the sample size. In general, when n is large enough, TC and ZC are essentially the same. ZC is for when sigma is none, when you are given sigma. So essentially, if sigma is none, use the Z distribution and E equals to ZC, sigma over square root of n. If sigma is unknown, use the T distribution with degree of freedom n-1, TC S over square root of n. I want to remind you again that there is a table on the PowerPoint here that tells you what ZC is for each value of C. C is the confidence level. So here you can see what are the possible value of ZC for the given confidence level. So next, we want to learn how to estimate the probability of success in a binomial distribution, otherwise called the population proportion. So to find the population, to estimate the population proportion, we use the sample proportion p hat, which is x over n. X is the number of success, n is the sample size. For example, if we have a class of 50 students and we have 30 female students, then the proportion of female students is 30 over 50, which is 60%. The sampling distribution of sample proportion has mean the population proportion. And it has standard deviation, square root of PQ over N. So we use the Z distribution if NP is greater than or equal to 5 and NQ is greater than or equal to 5. Essentially, we are saying N is large enough so that NP is greater than or equal to 5. Once we have that, we can compute the margin of error using ZC from the Z distribution, ZC times square root of PQ over N. So, and as we have the margin of error, we subtract it from the sample proportion, and then we add it to the sample proportion to have the confidence interval for the population proportion. We will look at an example here. So suppose that 800 students were selected at random from a student body of 20,000 and given shots to prevent a certain type of flu. All 800 students were exposed to the flu, and 600 of them did not get the flu. Let P represent the population that the shot will be successful for any single student selected at random from the entire population of 20,000. So P is the proportion of successful shot. Let Q be the probability that the shot will not be successful. That is 1 minus P. So having the sample size 800, we have that 600 of the 800 did not get the flu. So R, the number of success, is 600. We are going to use this to find the population proportion P hat, and then the population, the sample estimate for failure. So P hat equals to 0.75, Q hat equals to 1 minus 0.75 equal to 0.25. So we can observe here that both NP and NQ are greater than or equals to 5, so we can use the Z distribution for proportion. And using the formula, ZC equals to 2.58, E equals to ZC square root of PQ over N, we replace it into the formula to have 0.095, which we will add and subtract to the sample proportion P hat to get 0.71 to 0.79 as the confidence interval. So let's use calculator to do the same thing. I'm explaining first, then we can use calculator. If you are ready, get your calculator.
I'm ready.
So you can clear it if you like, and then go to start.
Okay.
And then from start, go to test.
Got it.
So you will go now down after 8, 9, 0, you will see A, which is 1 proportion Z interval.
Okay.
So you need to know X here was 600. That is the number of success. N was 800. The confidence level here was 99%. And we can calculate. Do you see the confidence interval?
Yes, I do.
Okay, 0.71 to 0.79. So this is how you can use calculator. Calculator is, according to me, much easier to use. So here is a summary of how to use calculator to do the computation for the confidence interval for proportion. So generally, when what we are saying is that when you do, for example, a poll for an election, you can use it to determine the confidence interval of the proportion of the population that is in favor of a certain candidate. So if you have the confidence level, you may subtract it. If you have the confidence level, you can, I'm sorry, if you have the margin of error, because sometimes they give the poll result with the margin of error. So most of the time it's like 3. So if they give you that a candidate has 47%, the confidence level will be 47 minus 3, 47 plus 3. But to compute the margin of error, as you use the formula that I showed you before. Now, suppose we are given the margin of error and we are asked to find the minimum sample size. For proportion, there are 2 cases we are going to consider. The first case is if a preliminary estimate for P is given to us. If there is a value for the confidence interval I'm sorry, if there is a value for P, the population proportion, then we use it with the first formula, which is P times 1 minus P times ZC over E all square. If there is no preliminary estimate for P, we will use 1 over 4. That is 1 over 2 times 1 over 2. Let's look at an example. A company is in the business of selling wholesale popcorn to grocery stores. The company buys directly from farmers. A buyer of the company is examining a large amount of corn from a certain farmer. Before the purchase is made, the buyer wants to estimate P, the probability that a kernel will pop. So what happens here is that he wants to buy corn from a certain farmer and he wants to estimate the proportion of corn that will pop. So he will buy a sample of corn and then use it to determine the estimate for the proportion of corn that can pop roughly. So if no preliminary study is made to estimate P, how large a sample should the buyer use? To do this computation, we need ZC, that is 0.95, E, which is equal to 1.96. You can see it here for 0.95, ZC is 1.96. Because no preliminary study was used, remember that we want a margin of error of 0.1, that is, the buyer wants to be 95% sure that the point estimate will be in error either way by less than 0.01. So E is 0.01. And we are going to have N equals to 1 over 4 times ZC over E. We will get 9,604. Here you don't need a calculator, it's just a simple formula. 1 over 4 times ZC. ZC is 1.96. And E is the margin of error which is given to you that you square here and get. Now, I told you there are two methods, one in which a preliminary study is not made about the population, and the second, a preliminary study is made in which 86% of corn purchased from this farmer will pop. So how large a sample will he need in order to be sure by not more than 0.01 that he will get the proportion of corn in general from the farm? So how many corn should he purchase? We will use the formula N equals to P times 1 minus P. Here P is 0.86. We will do 1 minus 0.86, which is 0.14. And then we multiply this with ZC over E square. So we will get 4625.29, which is approximately 4626 corn is to be purchased if a preliminary study was made, giving us an estimate for the proportion. .4 is the last section. In this section, we are going to compare two parameters. We compare them by subtracting them and compare it to 0. So if the sigma are known, we are going to use the Z distribution. When the sigma are unknown, we are going to use the T distribution. And we're also going to use compute the interval for proportion, difference of proportion. In all those cases, we are going to use calculator. So we are going to be talking about dependent and independent sample. For this chapter, we are not going to discuss dependent sample. We are going to be discussing independent sample. Samples are called dependent if their values can be paired, like in a before and after situation. You might want to know if a person is going to perform better when maybe he drink coffee and when he doesn't drink. So the same person will drink coffee and do a performance, and given a time for that coffee to disappear and do that performance, or do it without drinking and do it after the drinking. So that will give us a sense of what dependent sample mean. I might want to determine if left and right hands of individuals have the same strength. I will measure for the same individual, the left hand strength and then the right hand strength. So you know that a sample, two samples are dependent if their values are in pair. Otherwise, they are independent. So when sigma 1 and sigma 2 are unknown, we use the z distribution to do this computation. So the standard deviation of the difference of the mean is sigma 1. This is sigma 1 square. The square is missing here. For this. There is a square which is missing here, and I want to put it. Just 1 minute, let me correct that as we are on it. Okay, this is what we are supposed to get. But you are going to use calculator. I just wanted to fix the formula. It's sigma 1 square over n1 plus sigma 2 square over n2, taking the square root and multiplying by zc. Zc is the critical value when we are using the z distribution. So if the populations are both normally distributed or sample size are at least 30, when sigma 1 and sigma 2 are known, we use the z distribution to find the margin of error, which we will add and subtract to the difference for the sample means. Let's look at this example. In the summer of 1988, Yellowstone National Park had some major fires that destroyed large tracts of old timber near many famous trout streams. Fishermen were concerned about the long-term effect of the fires on these streams. However, biologists claim that the new meadows that will spring up under dead trees would produce a lot more insects, which would in turn mean better fishing in the years ahead. Guide service is registered with the park, provided data about the daily catch for fishermen over many years. Ranger checks on the streams also provided data about the daily number of fish caught by fishermen. Yellowstone today indicates that the biologist's claim is basically correct and that Yellowstone anglers are delighted by their average increased catch. Suppose you are a biologist studying fishing data from Yellowstone streams before and after the fire. Fishing reports include the number of trout caught per day per fisherman. So we have the formula here, and I want us to use calculator. We have data. Do you have your calculator?
Yes, I do.
So you go to start and then test. We will go down to 2 sample Z interval. We choose 2 sample Z interval because sigma 1 and sigma 2 are known. If we were given
you said Z, right? Not T.
Z, 2 samples
Z.
Z,
Okay.
because the sigma are known.
Okay.
So if we were given data, we would have entered the data in L1 and L2. But in this case, we have statistics. So we will go to start. You take the cursor to start and press enter. It is now going to ask you, what is the standard deviation of the first population? Can you see that? Sigma 1.
1.9.
1.9. And sigma 2.
2.3.
2.3, good. So we are going to enter the number of success, the sample mean for the first population, X1 bar.
5.2.
And the sample size.
167.
167. Now we enter information for the second population. Sample mean is
6.8.
And sample size
125.
Good. So having this information, we will look for the confidence level. The confidence, they ask us to compute the 95% confidence interval. So the confidence level is 0.95. Then we calculate.
And then I got 2 negative numbers in parentheses.
Yeah, so the confidence interval for the difference is negative 2.096 less than or equals to mu1 minus mu2 less than or equals to negative 1.104.
Yep, that's what I got.
Yes. If we were not using calculator, then we will find ZC and use the formula to compute the margin of error 0.5. And then take the difference between the 2 sample mean, 5.2 minus 6.8, and subtract the margin of error, add the margin of error to get these 2 negative numbers. These 2 negative numbers will help us to determine the sign of mu1 minus mu2. So because this difference is negative, both numbers are negative, it means this difference is negative. That will mean mu1 is less than, mu1 minus mu2 is less than 0. Let me write it here. So when we have negative 2.096 0.96 less than mu1 minus mu2 less than negative 1.104. Then mu1 minus mu2 is less than or equal to 0. It's negative, meaning that mu1 is less than mu2. That the average catch before the fire is less than the average catch after the fire, meaning that fires have improved fishing. Do you understand what we are saying here?
Yes.
That means the average before is less than the average after. So that's the interpretation we have here. So these are the instructions to use the calculator. Now, when sigma is unknown, we are going to use the calculator the same way we use the t distribution, and we are going to use two sample t interval when the sigma are unknown. When the sigma are unknown, the formula is, we are having the same situation here where we should put square here. This time it is working. I was doing this before and it wasn't working. So we are going to use the sample standard deviation in place of the population standard deviation. And the degree of freedom is the minimum of n1 minus n2, n1 minus 1, n2 minus 1. And we use it to find the critical value TC, which in turn is used to find the margin of error as in this formula. But as I told you before, it is easier to use the calculator. So let's look at this example. Alexander Burberry is a professor at the Medical School of the University of Zurich, where he is director of sleep laboratory. Dr. Burberry and his colleagues are experts on sleep, dreams, and sleep disorders. In his book, Secrets of Sleep, Dr. Burberry discusses brain waves, which are measured in hertz, the number of oscillations per second. Rapid brain waves, which is wakefulness, are in the range of 16 to 25 hertz. Slow brain waves, sleep, are in the range of 4 to 8 hertz. During normal sleep, a person goes through several cycles, each for about 90 minutes, of brain waves, from rapid to slow and back to rapid. During this sleep, brain waves are at their slowest. In the book, Professor Burberry comments that alcohol is a poor sleeping aid. Contrary to what most people think, when they drink alcohol, they sleep faster, but they don't sleep really. So we are going to look at this study and determine whether the population of those who take alcohol sleep less than those who does not take alcohol. So in one study, a number of subjects were given half a liter of red wine before they went to sleep. The subjects fell asleep quickly, but did not remain asleep the entire night. Towards morning, between 4 and 6 a.m., they tended to wake up and have trouble going back to sleep. Suppose that a random sample of 29 college students was randomly divided into two groups. The first group has 15 people, was given half a liter of red wine before going to sleep. The second group, made of 14 people, were given no alcohol before going to sleep. Everyone in both groups went to sleep at 11 p.m. The average brainwave activity between 4 and 6 a.m. was determined for each individual in the group. And we have the following data. So for this example, we are going to use data. Let's go to our calculator so that we enter data. You will go to start and then you can see the whole data is there. Take your cursor to L1, click clear and take it down, and you will clear the values. So on L1, we want to enter the brain waves of the brainwave activity between 4 and 6 a.m. for the first group, the group that took alcohol. We have 16. If you have trouble, let me know.
So all of these data or all of these numbers are going in L1.
Yes.
Okay. Okay, I inserted all of the numbers.
Okay, now let's go to the second group. So if we were to use statistic, we have the mean and the standard deviation for the first group. Because we are going to use the calculator for the computation, we don't really need to use it because we will use data. So for the first group, we will enter the values in L2.
Okay, I inserted all those values too.
Okay, so now we go back to start, then test, and we go, I think, to 10, which is 2 sample T interval. And we will choose data. Depending on the calculator, most calculators have L1 and L2 as the line you are using. So otherwise, you will change it here. Like list 1 is L1, list 2 is L2. Confirm that it is right. And then we look at the confidence level. Here we want a 90% confidence level.
I put that in.
Pool, you keep it as no. I want to explain what the pool means is that when you have the standard deviation are unknown, but you know they are equal, then you will use the pool. But we are not going to discuss pool. It's just a special type of situation in which even though the standard deviations are unknown, they are equal. So we will say no for pool and then calculate.
I got 11.8 868 and 14.254
Okay,
for like the two numbers.
those are the minimum and the maximum number. So using those, if we were doing it manually, this is what we will get. You will see that your answer is not exactly the same as this one. That's not a big deal. It's almost the same. If you are doing a test or a quiz, always choose the answer that is closest to yours. This is due to the fact that when you are using calculator, you don't round up. It does everything, especially as we enter data, you get this kind of situation. But it's not going to be a very big difference. So now, what we want to observe here is that the two numbers are positive, which means that the difference is positive. Do you understand what I mean?
Yes.
The difference is positive. So if we look at what we did before, here will be positive, mean mu1 is greater than mu2. Mu1 is greater than mu2 here will mean that we are no more discussing this. It would mean that the brain wave of those who drank alcohol is higher between 4 and 6 a.m. than the brain wave of those who did not drink alcohol, meaning that alcohol is a poor sleeping aid. It only makes people to think that they are sleeping, but for real, they are not. And this is a researched sample that we use. So sometimes you may have that question to decide what is the conclusion. To make those conclusions, either both numbers are negative and you will say that the difference is negative and compare the difference, or both numbers are positive and you will say the difference is positive and compare the difference. So we can do the same thing for the difference of proportion. That's the last part. Here we will check if we can use the Z distribution by comparing the expectation, that is N1P, 1 N1Q1, N2Q2, N2P2, and all must be greater than or equal to 5 for us to be able to use the Z distribution to compute the margin of error that you can see here. Is the margin of error. Which we will use calculator to do. I think you can see that calculator is much easier than do it manually. So let's look again, a research by Professor Buberly on sleep. In his book, Secrets of Sleep, Professor Buberly described research on dreams in the sleep laboratory at the University of Zurich Medical School. During normal sleep, there is a phase known as REM, that is rapid eye movement. For most people, REM sleep occurs about every 90 minutes or so, and it is thought that dreams occur just before or during the REM phase. Using electronic equipment in the sleep laboratory, it is possible to detect the REM phase in a sleeping person. If a person is wakened immediately after the REM phase, he or she usually can describe a dream that has just taken place. Based on a study of over 650 people in the Zurich Sleep Laboratory, it was found that about 1/3 of all dreams reported contain feelings of fear, anxiety, or aggression. There is a conjecture that if a person is in a good mood when going to sleep, the proportion of bad dreams might be reduced. Suppose that two groups of subjects were randomly chosen for a sleep study. In group 1, before going to sleep, the subject spent 1 hour watching a comedy movie. This is supposed to give them a good mood. In group 2, there were a total of 175 dreams recorded, of which 49 were dreams with feelings of anxiety, fear, or aggression. In group 2, the subject did not watch a movie, but simply went to sleep. In this group, there were a total of 180 dreams recorded, of which 63 were dreams with feelings of anxiety, fear, or aggression. Before we move to the next slide, I want us to enter this information into the calculator. So you are going to do start again, and then test. We will move down to, after T interval is 1 proportion Z interval, then 2 proportion Z interval. We want to choose 2 proportion Z interval.
Which one do we go to again? I'm sorry, I got lost on that, on the second part. So I
start,
went to, yeah, stat and then tests. I just didn't hear the last part of which one to go to.
okay, you will see that list. You scroll through the list looking for 2 proportion Z interval.
Okay. Got it.
Okay. So 2 proportion Z interval, you press enter, and we will begin to enter the information we have here. X1 is what they have as R1 here, the number of success. So we will enter 49. N1 is 175. X2 is R2, which is 63. N2 is 180. You have these values. Now we are looking for the confidence interval. Have you entered all these values?
Yes, I did.
So we now want to look for the confidence interval. The next thing they're asking, which are sometimes questions you have on the quizzes or tests, is the sample proportion. Sample proportion is the number in favor divided by total. The proportion is the small number divided by the bigger one. And so we are not using the formula, we want to use calculator. So we want to find a 95% confidence interval. So this is 0.95.
And then calculate.
Yes.
I got, for the two numbers, negative 0.1663 and then 0.02634.
Good. So I was telling you about how to find ZC. In this PowerPoint, several times you will use this table. You don't really need it because you can use calculator, but you might need it for the minimum sample size. For 95% is 1.96. I just want you to see where to get the ZC on a table. But actually this ZC, when they give you 0.95, they are actually asking you find the Z value so that the area between minus Z and Z is 95%. If you know how to answer that question from chapter 6, you will be able to find the ZC also using your calculator. Anyway, so we move to the next slide. This is the margin of error. And we have negative 1.66 and 0.026. So for proportion and the Z interval, there is not big deal. The difference is not as much as for the T distribution when we are using calculator, because also for the T distribution, we are using a kind of table for the TC, and that TC is rounded up generally, and that is where most of the difference that you might be perceiving, even as you will be doing your homework using your calculator, you might feel like your answer is not exactly the same as the one in the book, because the book is working on it manually. So we want to observe here that these two numbers are not negative. Do you see that? These two numbers are not of the same sign. Do you understand what I mean?
Yes, I do.
Okay, meaning we cannot say they are positive, we cannot say they are negative. So that means that we cannot conclude. And actually, it means the tests have failed. Meaning that we cannot tell whether good mood can determine whether you will have nightmare, bad dreams, and horrible dreams and things like that. But for a research like this, you might want to go back to question, does watching comedy actually produce good mood? That is just another observation we can make. Here we are saying that watching comedy movie cannot prevent bad dreams, because those are the type of things in science that people don't understand well. When a scientist will come up with the conclusion we have in this book saying that no, having a good mood before sleeping cannot make you not have dreams, bad dreams. Somebody looking at that study will say, I am not sure. The question could be that, does watching comedy actually produce good mood? Maybe we should find a way to produce good mood and see if it is not going to prevent nightmare. Do you understand what I'm trying to say here?
Yes, I do.
Okay, so when you have confidence interval for the difference, the next thing is to check if the difference is positive, negative, or neither. When it is neither, no conclusion. When it is positive or negative, you can decide which conclusion to make. So here is what I discussed before when the sample, when the population standard deviation are the same, but I do not ask you questions about that. So we are actually done at this. So this is one of the, you are welcome. This is one of the longest chapters. So we went a little bit above an hour. If you have a question, please don't hesitate. Let me know. And if you are taking your quiz after the first attempt, if you like us to have a Zoom session to discuss, or if you are doing your homework and you are not understanding it, let me know. I can find time and we will arrange to meet on Zoom and look at it. Don't wait until the end or after during the exam, because you cannot do much at that time.
Okay, sounds good. Thank you.
You're welcome, Alex. Have a good night.
Thank you, you too.
Thank you.